Okay, thank you. So if standards are not followed, it will be very difficult to produce certain things. Because for instance, if you are designing a part and you have designed it to your own specifications without following standards, if you want to machine it, there are some of the even the machinery that may be used to machine, you may have to somehow produce everything afresh. Okay. For instance, if we are trying to produce boats, okay, say boats and nuts, and we are not following standards, you decide to use your own, whatever that design that comes to your mind, you produce and then you are making it. You will see that even the making of the boats itself, cutting of the thread may be a problem because you may not have your own specification that you put out there. You may not have the machines that you may use to cut them. Like if you look at the lathe machine, you can use the lathe machine to cut threads. You can cut threads on the lathe machine, but there are limitations, okay? And if you don't follow the standards that are laid out, the lathe machine has been designed to handle certain items or to be able to work within certain range. So if your thing that you've designed on paper is out of the range that is supposed to work on, it means that you have to maybe modify the lathe machine or maybe produce a new lathe machine altogether to be able to fit your purpose. Are we okay? And that can be very expensive to do. That is why it is important that designs follow standards. All right. Just imagine if one boat manufacturer produces, say, 20 millimeter boat with 2.5 millimeter pitch. The same boat produced by another manufacturer had 2 millimeter pitch. Another made it with a left-handed thread. Which one will you know and how to order? But it's still 20 millimeters, so it's say M20. But the pitch are different. Some will be left-handed thread, some right-hand thread, and maybe a pitch is having 2.5, 2 millimeters or 1 millimeter. And if they are like that, though it's 20 millimeter bolt, but you'll be confused, don't know which one to use. Or even if you buy one, it may happen that where you are going to use it, it may not fit in there. Assuming there's a right-hand thread, all right, threaded hole where you have to insert the bolt, and then you go and buy a bolt and it's left-handed. It's not following the standard. Let's say the pitch of the threaded hole is 2.5, but the bolt is 2 millimeters in pitch. And that becomes confusing, becomes difficult. And therefore, manufacturers follow the standard and they produce the items such that wherever that they send them internationally to be able to fit in to serve the purpose. And because the standard that is there, any manufacturer that is there following the standard are able to produce uniformity. So it doesn't matter which manufacturer is coming from. At the end, when you bring them together, they are able to serve the purpose that they are meant for. Okay, a code is a set of specifications for analysis, design, manufacture, and construction of an item. The purpose of the code is to achieve a specific degree of safety, efficiency, performance, or quality. That's the essence of the code. The standardization of the parts and units covers the following. We have general standards, classification, and terminology, method of calculation, and drawing standards, machine design standards, which include basic specification of machines, connections, and overall dimensions. Production standards covering the manufacturing process, the processing tool normally used, quality level and operational standards for the material of construction, quality indices, manufacturing specifications, and testing procedures. Then the standardization of machine parts provides for one, the mass production, which requires little labor input and reduction of metal waste due to minimal chip removal. Okay, so we can do mass production. We can produce several quantities of the item, right, at a time, and the labor is minimized because the item we are producing is just similar at a time. So labor can be reduced, labor input will be reduced, and there'll be minimal metal wastage. Then we also have the possibility of using standard cutting and measuring tools, easy replacement of damaged parts during repairs. Designer has an easier task in terms of labor and improving the quality of manufactured goods. Most nations have their own edition of standard documents, which take into account the recommendation for International Organization on Standardization. And this is necessary to ensure interchangeability of parts, okay, and standard units of machines measured in various countries. All right, so it will help to ensure the interchangeability of parts. For instance, if you look at cars, most of the vehicles that we have, they are cars, maybe saloon cars, their tires can fit one another. So if one is driving a Toyota and maybe the other person is Honda, and maybe you remove the tire of the Toyota, it could fit that to the Honda because it has been designed to standard. The number of bolts that it's used, all right, and then the diameter where the bolt should be sent, put, and everything is designed to standard. So we can easily interchange without any problem. Okay, standardization bodies include the following that we have here, the following list. We have the Aluminum Association. We have the British Standard Institute, the BSI, and we have the American Gear Manufacturing Association, AGMA, then Industrial Fasteners Institute, IFI. We have the American Institute of Steel Construction, the Institution of Mechanical Engineers, and then the American Iron and Steel Institute, International Bureau of Weights and Measures, then American National Standard Institute, and many of them, and all these ones that are there. So these are all standard organizations that are there. All right, so they are the standardization bodies that are available, and there may be some other ones. ISO, which is an international body which inputs forward recommendation considered suitable for international agreement on metrication. ISO R indicates an ISO recommendation followed by the relative number R of the recommendation. And these recommendations are the basis for British standards or are intended to be used pending the issues of a standard at some later date when definite agreement is reached. We also have the BSI, all right, then the British Standard Institute is the authority for instrumentation of the metric system of engineering to British standards. These are written as BSIRY or BSIRY, that one. And it indicates the British standard followed by relative number and by the year of the implementation of the agreement for the standards to be in use. Okay. A good design should be such that it can be easily produced by the designated engineering production method. And normally the shape of a machine part and the quantity determines the manufacturing process that should be used to produce that particular part. Okay. And therefore, design parts for manufacturing are normally in this class of shapes. We have cylindrical shaped and spherical surfaces, that can be suitably machined in lathe machines. You can machine spherical surfaces or cylindrical surfaces on the lathe, and the drill presses. All right. Cylindrical surfaces could be done on the drill press. We have the horizontal boring machine tool, which can do that. I think, are you doing manufacturing technology this time?
Yes, sir.
Yes, sir.
Come across most of these machines that we're talking about here. And then we have the cylindrical internal and external cylinders. These are shapes or surfaces that could be done. And then we can, if we design the parts having such surfaces, then we know that this could be machined easily. Okay. Then we also have plane surfaces that can be easily machined in planes. Sharpness, milling machines can do that. Surface grinding can be done, right? So we have the grinding machines which are there. The planing machines are there too, which can do it. And then I think we have shaping machines there. Then we have helical surfaces which machined in thread cutting, thread milling, and thread grinding machines, which can be machined in these machines. Okay. So if the helical surfaces is helical, we could use the lathe machine can produce some of them. We could use some machines tools in the workshop like the tap, okay, and then the die can be used, right? Then we also have the involute surfaces which are machined in gear cutting and gear finishing machines. So we have machines that could produce these involute surfaces correctly. Then we also have blank manufactured from blank manufacturing operations for components and units with surfaces that are not to be machined. All right, so there are some parts that could be manufactured or produced using the blank method. And this method is where we are using areas where we have die to produce a part. So we stamp the part into the die to produce the product to form the shape that is needed. And the condition under which the foundry pattern of forging dies are machined also govern the production of this type of parts. And then the main criteria for international standardizations are one, the improvement in universal technical communication and mutual understanding. Okay, so it doesn't matter where the part is coming from, so long as they follow the standard. If you are in this part of the world, by looking at it, you'll be able to understand what they mean or what the part is meant for and what it can do, right? Because the standards have been followed. But if they have done something to their own without following international standard, you see that you obtain the product and you will not be able to understand how it will relate or work with the existing facilities that we have here. Okay. Then the second one is facilitation of international exchange of goods and services. So that will also help. If things have been standardized, there can be exchange of goods and services. All right, so we can do export and import. And anything that you export out there, because you are following the international standard, there is mutual understanding between the two countries and everything is accepted appropriately. See, there are times when like in Ghana, for instance, where we've had problems with our exports, especially in the area of the agri sector, where you've heard in the news that European countries or Europe have banned some vegetables coming from Ghana because they are not following some standards, okay? So internationally, even the chemicals that are used for spraying these products and all that, everything has to be to standard. So when they obtain the product and they test and they realize that no, there are certain things in there which does not correspond to the standard or what is been agreed on, then they will decide to boycott products from this side. Okay, and it's the same. There are times when that's why we have bodies like this is the Food and Drugs Board there. They are there. We have the Ghana Standard Authority, and these bodies are there to ensure that standards are followed within the nation, that anything that is being done follows the uh, laid down agreed standard, so that there will not be any problem anywhere. Then we have the removal of technical barriers to trade. So there will not be any barrier. There can be transfer of technology from one country to the other when standards are followed accurately. All right. Some benefits of standardization. So we have the general benefits. Uniform technology is created, sizes and dimensions are coordinated and adapted. Function requirements and characteristics are specified, okay, and unambiguous testing methods are established. So everybody is able to follow and understand and be able to know what is happening. So there's no confusion anywhere. Then we have the benefits for the government. We have regulatory activities, okay, public procurement, public works projects, communication, technical support to social projects, and then to the industry, market research, and then development. All right. And there we have engineering, tooling, estimating, ordering, works, order planning, purchasing, component production, assembly, inspection, storing, warehousing, marketing, distribution, transportation, installation, maintenance, repairs, and then the dismantling and recycling. If standards are followed, all these things can easily be done or achieved, okay? And also support to management systems. All right, then to the consumers, those who are going to benefit from those items directly or indirectly, we have a source of information. All right, so to the consumer, if the standards are there, when you are to purchase something or buy something, you have an information that this is the specification of the item that I'm buying. So in that case, you have that knowledge that when you are buying the thing, you ensure that the item that you obtain is able to fit in the laid down specifications. Okay. Then the application of the performance approach and the creative analysis, source of complaints, more balanced technical regulations. So these are some of the benefits for standardization. Okay, then do you have any question based on what I've said so far before we go to the next topic? Any question?
No, sir.
Okay. General classification of machine parts. Okay. I'm dealing with machine design, and mainly the machine is made up of different parts. Okay, but we can classify them generally. And in design, what is done first of all is to design the various elements, okay, the elements or the parts of the machine before assembling or bringing them together to form the whole, right? So we can categorize these parts into the following. The first is joints and fasteners. So we have joints and fasteners, and there are two types of this. We have permanent joint and then we have temporal joint. Okay, temporal joints are joints that we can separate, and the permanent one, they are secured, and no separation is intended for permanent joint. Okay, and any joint that is formed through welding, we consider it as permanent joint. Through soldering is permanent, or riveting is also permanent. Okay, for instance, if there is a rivet, right, you rivet two metal plates together, you cannot separate them together. I mean, you can't separate them easily unless you break that joint by destroying the rivet. Okay. If it's welded together, you can't easily go, and you have to maybe cut it off, cut the weld off to be able to separate the parts. Soldering, similar thing. Okay, but we also have the temporal joint in cases where like screws are used, bolt and nuts are used. We have key and slotters, all those things. In cases where these are used, we can, the temporal joint will allow for removal or separation of the joint easily. We can bring them back. And mainly you could use the same joint element to bring them back. For instance, the joint is a temporal joint where we've used bolt and nut. If you want to separate the joint, you could just use the spanner to open the bolts and nuts, then the joint is separated. Okay, but if you want to put them together too, you could use the same approach. You could use the same bolt and nut. So long as they are in good condition, you can put the joint together, the two parts together to form the joint. Okay, so the first is the joints and fasteners. Then we have the transmission mechanisms, and these are made up of drives. They are made up of shafts, clutches, and other things, and they transmit energy or power with rotary motion and are divided into two. The first is tooth gearing. Okay, in this case, we are dealing with gears where there are teeth, okay, on the gear. Then we also have friction drives. Okay, so friction drives are things like belts, rollers, or roller drives with rigid rolling bodies. If you have roller and roller drive, like there are cases where you have two rollers that are rolling against one another, and one is driving the other, and it's mainly through friction. Okay, so there's friction between the two rollers. So as one is rotating, it will be driving the other one. Then we also have the belt drives, which also use the friction uh, method. Okay, and then in cases where we have gears like tooth gearing, like things like chain drive also is the one having tooth. Okay, and then the chain. All right, so that one is not dependent on friction. And that is why you see that for tooth gearing, usually you see lubrication of the meshing element, okay? Because we want smooth immersion so that there will not be a lot of noise or heat produced, all right? Because that would be undesirable. But for friction drives, friction is necessary, so we have to ensure that lubrication of the drives are avoided. But if you put a lubricant there like oil, there's a belt rotating, okay, let's say a belt and a pulley, and I put oil on top, you see that it will begin to slip. Right? The belt will be slipping over the pulley, and you will not be able to achieve the intended um, purpose. Okay. Then we also have the rotating transmission parts, and these are usually mounted on shafts to form transmission mechanisms. They consist of tooth gears, pulleys, chains, sprockets, etc. Shaft transmit a torque along their axis, whereas axial carriers rotary components without transmitting a useful torque. Okay, so here when we talk about shaft transmit a torque along the axis. Right? If there's an axle doesn't transmit torque. All it does is to carry a rotary component. So the component will be rotating on it. So there's no power being transmitted through the axle. And you can see this in even this four-wheeled trucks. You know, this truck that the truck pushers have been pushing. You see some bars at the back and the front side on which the wheels are mounted. And generally the wheels will be rotating, but those bars don't rotate. Okay. And even the vehicle, if you see the vehicle, there's automobiles, either trucks or cars. The parts where the vehicles are not, for instance, if you have a car that is a front wheel drive, the back tire will be rotating all right, but it's the front that is driving. So the back tire is rotating on what we call the axle. And that one is just there, it's the straight back carrying the tires, and the tires will be rotating on it, but it doesn't transmit power. But the power is transmitted through the shaft. And if it is a front wheel drive, you see that the engine power is connected through the shaft to the wheel to be driving the wheels. Okay, so this is just giving us some differences between a shaft and axle. All right, so shafts are linked by couplings or clutches. Couplings do not allow disconnections of the shaft during operation, whereas clutches enable shaft to be engaged and or disengaged from each other in the course of operation. So these are also some differences here between the type of connection, either coupling or clutches. So if you have two shafts and you want to connect them together, you can use the coupling to connect them, okay, or the clutches. And usually in the engine, right, in the engine of a vehicle, you see that the crankshaft, which is a shaft which is carrying the power coming from the engine, that power can be transmitted to the wheels of the vehicle through the clutch, okay? And usually into the gearbox of the vehicle, we have a shaft there. So shaft, which is a crankshaft coming from the engine, and another one into the gearbox. And in between them is a clutch. So if you want to send power from the crankshaft to the gearbox, which will go to the wheels, you need a clutch to be able to transmit the power. So the clutch will either engage or disengage. Right. So if it is engaged, then it means that there can be power flow. But if this engages, that means that there is no power flow. Okay. But if this coupling is like somehow something permanent. All right. So long as there is power coming, it has to go to the output wherever it's going to without a means of separating it. All right. Are we okay? Then the shaft and axle run on bearings, right? They have to run on bearings. It's very necessary. Bearings are either sleeve or anti-friction bearings, such as ball and roller bearings. Part with translating motion are supported in linear bearing. They have linear bearing like slideways or various so like the slideways of various shapes or linear ball and roller bearings. The bearings are then supported by the basic parts of the machine, such as the bed, okay, and then the base and the housings of the machine. They support the bearing, and there can be free rotation through the bearing. On the shaft can be rotating on the bearing, within the bearing. So these are the rotating transmission parts. Then we also have motion conversion mechanisms. Right? We have motion conversion mechanisms. And these are those that convert motion from rotation to reciprocating and vice versa. All right, so something like the slider crank mechanism is to convert motion. Okay, if you look at the piston of an engine, the piston only moves in a straight line. Okay, it translates, moves within the cylinder of the engine. Okay, but we want to convert that motion, reciprocating motion, into rotational motion. And that is where the connecting rod and the crankshaft will come in to assist to help that. Okay, so that is a sample of the slider crank mechanism. All right, so you can also convert rotational motion to reciprocating motion. All right, so these are the motion conversions. The motion is obtained with velocities varying along a given path according to a given law, or motion along a complex path obtained by means of a lever and a cam mechanism using a cam, eccentric, and rules. So we have that one too there, where we have the cam and the follower, which also can help us to convert motion. Then we also have elastic elements. These comprise elements such as coil and leaf springs, which are used to protect against vibration and shocks, such as in automobiles. Okay, they are also used to store energy, which is released to do useful work or over a prolonged period of time. Example, clocks, watches, and spring actuated mechanism. They are also used to provide for return strokes in mechanisms by providing tension such as in cams. Okay, so they can provide tension. For instance, in the automobile again, the internal combustion engine, okay, IC engines, you see that we have that puppet valve, and that puppet valve which either opens to allow fuel air mixture to enter into the engine, or opens to allow the exhaust gases to go out. Right, the cam directs that the opening. So the timing, there is what we call the timing belt or the timing chain, which connects the crankshaft to the camshafts. And the camshaft will be opening the valves. What the camshaft does is only to push the puppet valve down for the valve to open. But the spring, which is an elastic element, will have to restore the valve back to its initial position, okay, to close the valve. So if there is a spring loaded member that is there. If you push down that member, the spring stores that energy which we have used to push it down. Then after that, what will happen is that the spring will now return the object back to its initial position using the energy which it has stored within it. Okay. Then we also have the energy conversion mechanism. These are part of their mass to do work. It use part of their mass to do work. Example, pendulum clocks, flywheels, etc. They ensure more uniform motion to restoring stored energy for increasing the force of a blow, or they absorb shocks as an impact type mechanism. Okay, so either it absorbs the shock, or it can store energy and then it will restore it when it is needed. Again, if you look at the design of the engine block, for instance, on the connecting rod outside it, they've mounted a crank they've mounted this what we call the flywheel, sorry. And this flywheel, because if you look at the firing order of the engine, it's intermittent and the engine fires intermittently. Okay, so at a point, assuming you have only one cylinder engine, at a point there is firing, like there is power, is producing power. And at a point it's the exhaust stroke. The exhaust valve have to open for the exhaust gases to go out. At that point, no power is being produced. So if you take the four-stroke engine, for instance, we only have one power stroke out of four stroke. Okay, so we have the intake where power will be, the air fuel mixture will enter into the combustion chamber, and then we have the compression stroke. Then after the compression stroke, the power stroke. So the power stroke will produce power. Then the exhaust stroke will come in for the exhaust gases to go out. In all these strokes, the piston have to be going up and down. So if the power stroke is only one out of three, what will cause the piston to return back to its initial position, like the compression stroke, what will cause it to go down, like the intake stroke, what will cause it to go up again to expel the exhaust gases, is a flywheel. So when a power stroke comes in and produces the power, the flywheel stores that energy. So it keeps rotating. So though there is no power being produced again, that energy which has been stored can cause the piston to go back and forth until all the cycle is completed. Okay, so that is what that also does. Then we have the lubrication and dirt control protectors. Okay, so here this consists of seals, oil rings, oil drips, etc. They protect the running parts from dirt and effect lubrication, thereby prolonging the service life of the machine. Then we also have the control mechanism. These comprise units and mechanisms which affect control of motion, direction, etc. of machines. Examples of which are limit stoppers, switches, solenoid, contactors. We have the photocells, ICS, etc., used to control motion, speed, and direction, and other things. So those are the control mechanisms. Then we have special purpose parts. These are parts of various specific machines, or more precisely, those most widely used in various groups of machines. Examples, we have typical components of power machinery, cylinders and pistons. Okay, cylinders and pistons, the valves, turbine wheels, blades, and disc of turbines, rotor and stator of electrical machines, etc. Types of transporting, typically transporting machinery are wheels, chain tracks of heavy equipment. All right, we have the train rails, we have aircraft screw propellers, and then we have the hoisting hooks and buckets. These are special purpose parts. So those are parts that serve some special, reserved for some special activities, okay? And they are related to specific machines, okay? They are not something that can be used anywhere, all right? Okay, thank you very much. Any other question? Any question based on this? Yes.
So please, you talk about the methods of joining shaft together for the transmission of energy. So with the coupling method, can you explain it further? I think that's how it is done.
Which method?
The coupling method.
Coupling.
Yes, sir.
Or a simple coupling is mainly joining the two shafts together, and usually with the use of what we call couple. So couple, when you say couple, you understand what it means. Couple is like there are two pairs, two identical items. Okay, so it's something like is having a flange. It's a part, an item that is having a flange on it. Okay, so one is on one of the shaft and the other one is on the other shaft. Then there are holes in within and on it, on the flange. So when you put them together, you can bolt the flanges together. Okay, so that will give you a very tight connection between the two shafts. You can only separate the shaft by removing the joint, by opening the bolts. Are you okay? So that's coupling.
Yes.
You can check on that if you are still there and don't have, if you still don't understand, just go to the internet, type coupling or couple joint. You see what I'm talking about. It's not something very abstract. It's easy to capture. Okay, any other question? Any other? All right, thank you very much. Our time is up. I have uploaded the video for our last lecture on the VS